How can Hawking radiation escape a black hole? Is it ethical to spread life in the solar system? And why don't we use the official exoplanet names? All this and more in this week's Overtime Question Show. Well, if you're seeing me outside, then you know that this is not this week's live question show. This is another episode of Overtime Questions. These are the extra content that we do every week when we do the question show. And that's because I was off last week in Europe chasing auroras. So my kid and I went to Iceland and Amsterdam, and we tried to see auroras. Did we see auroras? Oh, yes, we did. In fact, there was like one of the biggest solar flares in the last 10 years happened while we were in Iceland, and we got a chance to see the auroras, and it was epic. Anyway, so I'm going to talk a bit about how to see auroras at the end of this episode, so stick around for that. Otherwise, let's get into the overtime questions.
RTX agent, how does Hawking radiation work when nothing can escape a black hole's event horizon? The Hawking radiation isn't coming from the black hole, it's coming from the area around the black hole. And then the black hole is donating the material. So Stephen Hawking figured out this idea of Hawking radiation. He realized that black holes should evaporate over vast periods of time. And the way to understand this is imagine that if you just were in empty space, there was nothing, like no stars, no planets, no energy, nothing, just the vacuum of space with nothing in it, no fields, nothing. And if you were stationary, you wouldn't experience anything, right? There'd just be nothing. If you had detectors on your spaceship, you wouldn't experience anything. But if we accelerate, and this has sort of been demonstrated, been proven in the lab, that if you accelerate, then you start to experience radiation. And the radiation is coming from just space-time itself. There are just the fields that permeate the entire universe. And so when you're just stable, you're not interacting with any of these fields. But once you accelerate, then you start to experience these fields, and they appear as particles that are kind of, you experience this radiation that's coming at you only when you're accelerating. So not when you're just coasting, but when you're accelerating. And we know through the equivalence principle that, Einstein figured this out, that accelerating is the same as being in a gravitational well, that they are interchangeable. And so if you're experiencing a constant gravitational well, it should feel exactly the same as if you are accelerating through the universe. And so when you have an object that is close to a black hole, if you were sitting next to the black hole and you were no longer accelerating through the cosmos, but you're instead in the presence of this gravitational field, it's the equivalent of you accelerating, you're going to be experiencing radiation. Now, radiation can't come from nowhere. It has to come from somewhere. And the somewhere that it comes from is the black hole. And so from an outside observer, they're watching radiation slowly come from the black hole, which is just the consequence of this equivalence between acceleration through just space itself, interacting with the fields that permeate the cosmos, and the black hole's gravitational existence in those fields that permeate the cosmos. The two have to be identical, and so energy is released. So does that explain the question of why, in theory, radiation should be escaping? And the term for that is like Unruh radiation. TS Vlogs, we talk about the sun will be almost engulfing Earth in the next 5 billion years. We don't talk about the neighboring mass of Jupiter. Will Jupiter also expand similar to the sun, since it's also a gas planet? No, Jupiter will not expand. If anything, Jupiter is contracting. So as it cools down in the center, it is contracting slightly as it goes. And the sun isn't necessarily growing. I mean, it will engulf the Earth in about 7 billion years when it uses up all of the fuel in its core, but it's putting out more and more heat, increasing its luminosity. So like what's happening is it's converting hydrogen to helium in the core. The helium is forming this shell that is around the outside of the core. And it is sort of causing the sun to put out more heat. And in the next billion years or so, the heat will become so intense that it will actually wipe out life on the surface of the Earth. It'll boil the oceans and end life on Earth. 500 million to 1 billion years, maybe 1.5 billion years. But Jupiter doesn't have the same process. Jupiter doesn't have fusion in its core. It's not running out of fuel in its core. So Jupiter is just cooling down. Eventually, Jupiter will cool down to the background temperature of the universe. It'll just take a long time. Orson Zed, why don't astronomers use the official names of exoplanets? Is it because they're terrible at naming things and don't want to ruin a bad thing? So I don't know the official names of exoplanets, and I'm the kind of person who thinks that things should have really cool names. And yeah, the International Astronomical Union has bent to pressure and given exoplanets proper names. They voted, they've made them official, and the names are cool. They come from mythology, and they come from history, and they come from science fiction, and they're very cool. And yet they're just not easy to get the list of names. And so I just never think to get the names into my brain. But exoplanet names IAU. So Fomalhaut B is called Dagon, Arion, Orbitar, Dimidium, Galileo. So the planet 55 Cancri B is called Galileo, Brahe, Hala, Finlay, Hypatia, Ager, Puli, Sissy. Yeah, there's Cert. There's like mythology for each one of the names. This is great. And yet we just don't use them. And now that you've reminded me, I think I'm gonna follow up. I'm gonna try to get that list of names more readily available. I mean, the problem is there's like 5,000 exoplanets, right? And yet, I don't know, 150 have been given names. This is what we've been asking for. They've done it. They've delivered the names. Now it's our job to use the names. Like WASP 79b is Polera. There you go. Right? We always talk about WASP 79b, and it has a name. So, yes. There you go. Church discography. Could India beat everyone else to a human landing on the moon? I mean, if everybody doesn't land on the moon very quickly, then India could be the one to land on the moon. They are planning human missions to the moon, or at least they're planning an astronaut program. So they're building a human-rated rocket that can carry humans to space. They're planning on building a space station. And then this is the tech stack. This is the way you move forward. You build a space station, you send your astronauts into space, then you send missions farther away, and eventually you try to set foot on the moon. And of course, there's very well understood technology that was developed by NASA and now the Chinese. And so the Indians should be able to license technology and just follow in their literal footsteps. But it would mean that the Chinese are not able to do their missions to land on the moon. It would mean that the Artemis missions are canceled. It would mean that SpaceX isn't able to get their act together and land humans on the moon. Then the Indians have a crack at it. But I think like right now, there's too much momentum by other parties. They're going to get to the moon first. Michael Ranger, I realize that mistakes aside, ChatGPT is a personal science communicator. How does it hit you as a science communicator? It's crappy. It's not very good at doing its job yet. It hallucinates. It can't be trusted. If you're going to use ChatGPT as a science communicator, you are making a mistake. You need to trust and verify the things that it says with other sources to triangulate. Now, as a way to help you understand a complicated topic, it's terrific, and I highly recommend it. But you use it in the way that you would use a enthusiastic assistant, right? Someone who's like, really wants to help, but you're not entirely sure you can trust the research that they do. You need to double check and sort of build up a certain understanding of what they're capable of. And so that's where ChatGPT is at. Now it's getting better. But like, am I worried about ChatGPT taking my job? It's kind of like saying that you are a chef, and are you worried about a replicator taking your job? Right. So it's like if a replicator shows up and it makes, and it's $100 box, like a microwave, and anyone can put it in their house, and it makes an infinite variety of food at low cost, and the food is as good or better than the greatest chefs in the world could produce, then you just got out technology. You just got replaced. And yet the benefit is that human beings are being fed, right, for inexpensive costs. Like, how can you be against that? And so if or when the large language models come along and they are better than me, Like they're just objectively better science communicators than human beings and can provide at an incredibly low cost a very personalized education to anybody who needs it. I will gracefully cede the field. I will step away, step aside. But as long as people want to continue the human touch, I guess, then I'll have a job. And whenever we clearly see that nobody wants to be our patron anymore, everybody's moved on, then I will retire and just switch to the lumberjack portion of my career. Chris Eastman, from a science communication standpoint, what is the best way to bring science communication to the lay or ground level folks? I mean, I think it's just you do it, whatever you use, whatever tools you have at your disposal, whatever skills you have to communicate science to whoever is willing to listen. I think there's nothing more or less than that. And so, you can set up a telescope outside of a concert and do sidewalk astronomy, and people come and ask you what they're looking at. You can explain, they get excited, they want to know how to get a telescope. Boom, you just did some science communication. You can organize science in the pub in your local town where you bring in guest speakers, maybe at the local university, to talk about the projects that they're working on in a casual setting. Those are really fun. And regular people love science, they really do. And it's just that people don't get organized about making these things available. I mean, you have scientists selling out theaters to give talks about science. Like it definitely works, and there's definitely an interest there. It's just that people need to be organized and coordinate things. So think about how you can coordinate. If you have a podcast, if you want to create videos, if you want to write, there's lots of ways that you can reach an audience in the public. Normal Wolf, I love the thought experiment of an intelligent alien species with different senses. What would be the minimum for them to know outside their world? That's really interesting. I mean, I think about these potential alien species that are trapped underneath ice on a water world. And it's like, what do they know? There's no illumination. Maybe there's some kind of chemical illumination. And yet, for whatever reason, they've evolved an incredible amount of intelligence. And so, like, what can they perceive? They're probably very good at perceiving in the darkness. They can maybe use sonar to be able to understand their environment and detect prey and detect predators and threats. And maybe over time, because it was a complicated environment, they had to build up a large amount of intelligence. They built society and knowledge, problem solving. I mean, the kinds of things that human beings did. And you can imagine they would know that you could chip away at the ice that was above your head. And then maybe you could grab hot rocks that were down at the bottom of the ocean and carry them up and use them to melt your way up through the ice. And you can imagine this sort of incredible multi-generation project as they were trying to figure out what was at the top of the ice. And they would have a horrible discovery when they actually got up there to the top. And then they would figure that out and they would problem solve. And eventually they would understand their true place in the cosmos. So I think there's a lot of worlds. We sort of envision life forming on planets like the Earth, where you've got a terrestrial planet in the habitable zone of a sun-like star with trees and stuff. But we don't know what various flavors and forms that life can take. But we know that here on Earth, like, life has developed the senses to adapt to the environment that they find themselves in. We see in the colors that are most useful for the kind of illumination that the sun gives off. We hear based on the way sound moves through our atmosphere. We feel based on the kinds of substances that we're going to be coming across. We taste based on the kinds of chemicals that go into our mouths. And so alien species would be adapted to whatever environment they find themselves in. But many of them are going to be like us. And so you would expect them to have evolved the same kinds of senses. They would probably have some kind of vision. They would probably have some kind of hearing. They would probably have the ability to feel in their surroundings. Busy Billy B33, is the moon surface littered with precious rare metals delivered by meteorites? Yeah. I mean, like, when you think about some of the most productive mines on Earth, things like nickel, right? In Sudbury here in Canada, there's a nickel mine, and it's an old asteroid impact that people are mining the asteroid impact. And so there are going to be concentrations of metal on the surface of the moon where metal asteroids have slammed into the surface of the moon, and theoretically the metal is still available. So the problem is that on Earth, we have the atmosphere. And so if you have a meteorite hit the atmosphere, it slows down and you get the shrapnel raining down and landing on the surface of the Earth. And that's why you can walk around and you can pick up a meteorite just picking up off the surface of the Earth. You can pick up an iron meteorite, and they're very cool. But on the moon, there's no atmosphere. And so all of the objects are hitting the moon at the full speed. They're all going 10 kilometers per second. And so they vaporize. So you probably won't get the little meteorites in the way that we have them on the surface of the Earth. Like if there was a thick atmosphere, even like what you have on Mars, like Mars has enough atmosphere to slow down meteorites. They can hit terminal velocity and land gently on the surface of Mars. But you don't get that on the moon because there's no atmosphere. Pick Jahan, if everything seems to be orbiting something, what is the universe orbiting? The universe isn't orbiting anything because the universe is everything that is. If everything was orbiting something else, then now you would have to include that something else in the everything. And so you can never end that sort of thought experiment. Jack Westy, do you think that New Horizons will find another target flyby? I hope so. The machine that's going to be able to do this will be the Vera Rubin Observatory. It's going to come online in 2025. Like we're just 6 months away from first light for Vera Rubin. And then once Vera Rubin comes online, within a couple of months, it should find a whole bunch of new Kuiper Belt objects that are in the area where New Horizons is. It should find Planet 9. So hopefully it should find new targets. And New Horizons still has fuel in the tank. It still has destinations it could reach within its sort of flight cone as it's moving forward. And I know that Alan Stern and the rest of the people on New Horizons are really hoping they can do more science with this. Robert Allen, would you consider going back to school to become an astronomer? No, I don't want to be an astronomer. I'm happy being a science journalist. Like, I think there's a need for people like me to explain the things that are happening, to focus on the educating the public about what's going on with space and astronomy. And there's a place for the people who are actually doing the research. And, it is a symbiotic relationship, maybe a parasitic relationship. I don't know if I'd enjoy being a scientist. I kind of really like being able to flit around and look into the kinds of things that I'm curious about. And I think I would have a hard time just sticking my head down and focusing on one very specific kind of research for a long time. I don't have the attention span for that, I think. Giovanni Falmouth, are the Chinese trying to send people to the moon? Yes. The Chinese Space Agency has laid out in fairly concrete detail their exact plans for sending humans to the moon. So currently they've done 5 missions to the moon, the Chang'e series. Chang'e's 1 through 5. Chang'e 6 is coming soon. It's going to be another sample return mission. Chang'e 7 is going to be an in situ resource utilization mission. And then come 2030, they're going to have their human mission to the moon. And their plan is going to be very similar to what they did with the Apollo era, but I think it's sort of a bit of an improvement. So they're going to send 2 identical heavy lift rockets. So imagine like 2 Saturn V's. One is going to have the capsule and the service module, and then the other is going to have the lunar lander and the ascender on board. So the people on one rocket and the lunar hardware on the other rocket. And then the 2 rockets are going to go to the moon. And then once it's all in orbit, the astronauts are going to get into the lunar lander. They're going to go down to the surface of the moon. They're going to do their moonwalk. And then they're going to get back in their ascent module and they're going to come back up to orbit. They're going to meet with the capsule. They're going to fly back to Earth. They're going to ditch the lunar lander and the service module and return to Earth through the capsule. And they've tested out most of the parts of this mission. I mean, they're building the big rocket, but it's going to be an evolution of their existing heavy lift rocket. They've gone through this process of developing a mission to the moon, landing on the moon, taking off from the surface of the moon with their sample return mission. And also they've tested out keeping humans alive in orbit on board the Chinese space station. So they have tested out all the different bits and pieces of this plan to send humans to the moon. It's now just about putting all of the hardware in place. Building the heavy lift rocket, building the final version of the capsule, service module, the lunar lander, and then sending that all to the moon. And I think, so far they have been following their plan. I mean, their plan is like 20 years long. right? And they've got it in excruciating detail. What comes after the first mission, the second mission. Like, we know what their long-term plans are. And they're hitting their milestones. They're following it step by step by step. And so, you know, if NASA doesn't get to the moon by 2026, the Chinese will get there by 2030. Lost in Space, what are your thoughts on the newer aerospike rockets? So aerospike engines are a great idea. So the way they work is that the kind of engine that you need to get out of the atmosphere of the Earth is a different shape than the kind of shape of the rocket bell that you use in vacuum. And you can look at this example. When you look at the rocket engines on the bottom of Super Heavy, they're very small, very compact. When you look at the ones that are at the bottom of Starship, they have the three surface rockets, and then they have the three vacuum rockets. They're much bigger. And so it's just that, you know, when you've got the pressure of the atmosphere pushing against the exhaust plume coming out of the rocket, a different shape makes more sense. And so the idea with an aerospike is that you can change the shape of the rocket plume depending on the density of the atmosphere that's around the rockets. You start out, you're at surface level, you have one shape, and then as you pass through the atmosphere, you can change the shape and sort of try to optimize your flight the entire way, as opposed to what SpaceX does with just, they have the surface level and they have the air version, and then they have the vacuum version of their engines. So like, is it a good, I mean, they're potentially very exciting, and NASA was working on aerospike engines, and there's, you know, they're planning to have one on their X-33, the Venture Star. And for various reasons, the X-33 was canceled, and with it went their work on the aerospike engine. But there are other companies that are working on aerospikes. And I know Tim Dodd, Everyday Astronaut, he did a whole deep dive into aerospikes. So he can answer that question better than I can. William R., would you be in favor of seeding life elsewhere in the solar system? It just depends on whether there's any native life elsewhere in the solar system. So if we explore other planets in the solar system, like Mars, like Europa, like Enceladus, and we are certain that there's no life there, and that's a really tall order. Like, you know, it's hard to confirm a negative, right? You keep looking, and maybe there could have been life there, but you just didn't look comprehensively enough. But if we are sure that there is no life, then yeah, absolutely. I think life is better than non-life. Trees are better than rocks. So I think it would be interesting and useful and good for the universe if we spread life beyond Earth, because life on Earth has a limited time frame. I mean, it's just a matter of time before the sun boils the oceans and cooks all life on Earth and destroys the planet. We are on a timeline here, people. And so we are an actual being that has appeared on this planet, and we have within our power the ability to spread life out there into the universe. And I think it's our responsibility to do so. But that assumes that we're not going to destroy any indigenous life that's already there. So step one is absolutely make sure that there is no indigenous life on any of the planets or moons in the solar system. And then step two is see if we can grow stuff there. Let's spread life to those places. Jack Jenkin, what are your top 3 moons in the solar system? Titan, Triton, and Iapetus. So like Titan, obviously. Oh, and Ganymede. Okay, Ganymede. I'm going to go for 4. So Titan, obviously, like no explanation needed. Triton, this is the large moon of Neptune. It orbits backwards from the rest of the solar system, probably a captured Kuiper Belt object. It probably has geysers like Enceladus does. That's a cool place. Iapetus just looks bizarre. It's this weird yin-yang moon. Half of it is bright white. The other half is dark. How cool is that? I would love to see. And it's got this weird ridge that is like 10 kilometers high that goes around the whole moon. I would love to have this place explored. And then Ganymede. And Ganymede is a moon of Jupiter that's large enough that has its own intrinsic magnetic field. It's probably got a thick sheet of ice around a liquid ocean in its interior as well. It's just as interesting as Europa, maybe more so because of that magnetic field. So those are my 4 moons out of your 3. Which ones are important to explore scientifically? All of them.
As promised, I'm going to talk about how to see auroras, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, ScienceWorldRecord.org, Spiderswap.io, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. So I'm sure at this point, as we approach solar maximum, you're seeing more and more information about people seeing auroras in the sky, and you're wondering, how do I get in on that action? And so as we're approaching solar maximum, we're seeing more and more activity coming from the sun, more powerful flares, coronal mass ejections. That means that the auroras are visible farther away from the poles than they normally are. And so, for example, in North America, if you normally can only see the auroras in Iceland or northern Canada or Alaska, during really powerful solar storms, we can see them down where I live on Vancouver Island, but even into Northern California. You can see them into the middle of Europe. And then for the people in the Southern Hemisphere, people can see them in Tasmania or in New Zealand or even sort of around the Sydney area. So there's a lot of options if there's a powerful solar storm. So you have to do a couple of things. First, you have to find out how to track the current strength of solar activity. And NOAA has a website where they'll give you forecasts on what the various space weather conditions are and give you predictions for how much space weather you're going to have in your location. You can also download apps, and I'm sorry, I don't have any recommendations, but you can download apps that will send you a notification when there's going to be an aurora in your area, and then you can sort of use that to judge. But generally, you just want to stay on top of what is the space weather. There's lots of websites out there that'll tell you that. And then the second thing is that you've got to find your spot. And so you've got to find a place that gives you a clear view towards your closest pole. So for me, I want to look to the north. People in the Southern Hemisphere, you want to look to the south. And if you are sort of at around the 45th latitude or above, closer to the pole, then you stand a reasonable chance during a powerful solar storm of being able to see it in the sky. But you actually have to go out and do it. And so you have to commit. You have to go to your place. We'll give you dark skies, view to the pole. And when you get strong aurora activity alert, then you have to go spend a couple of hours in the cold, maybe, watching and waiting. And we're going to see increased auroral activity into 2025. So you're going to get a lot of chances at this. Most of the time, you're not going to see anything, but every now and then, it's going to blow your mind, and it's totally worth it. All right, good luck, and we'll see you next week.